So hi everyone, I'm going to talk about a few different things, states, events, and async messaging, specifically tied to REST microservices. Who here does any kind of engineering work with REST or microservices? Cool. All right, so I hope this will be interesting. So this is the Everyone's Guide. I hope you'll find it interesting. I think it's really interesting to use things like Postgres and MySQL and to use really standard practices. I find it's interesting to be able to take advantage of some of these features, though. Anyways, that's the area I'm targeting. So I'm Jason Swartz, up at Swartz Rock. I like to talk about technical matters like this. Usually I'm more in the Scala community. I wrote a book on Scala and run some Scala conferences. But I really just like talking about general programming as well. So I usually like to talk about APIs or Scala. So this fits. This is great. Some of the material for this talk comes from my time at Netflix, at Mesosphere, and from my current time at ClassPass, which is really revolutionizing the whole way that the whole fitness industry. So we're making it very modern, and we're doing the microservices route. We have a monolith. We're breaking it into microservices. This is the best way to do it. So it's a lot of fun to be able to learn these things and try them out here. So what we're going to do today, I'm going to go over a quick microservice app to show this as a background, and then get into immutable states, event sourcing, and async messaging. Hopefully before the beer runs out. No, there's lots of beer. All right. There's lots of beer here, folks. It's free beer. I shouldn't have to shout that, really. Okay, so tasks. I want to have a service. I want to offer tasks, issues, Jira. I want to have, a task which can be done, have a title or a assignee. So I'm going to make the whole thing as a big Rails app. No, I'm just kidding, because I'm here, I have to throw this in. I'm going to do a microservice. Maybe I'll have an issue service and a user service, and they talk to each other, and I'll have some nice endpoints so we can actually go in and get some issues or post them or put them. I know it's not very challenging for you folks. You're probably all familiar with this. What I want to look at is, if I do regular CRUD stuff and I'm using Postgres or MySQL or some other type of RDS, if there still are any companies left in business doing that, how do these events that come in through the API affect my database? So if I have an empty table here, ID updated, title assignee done, awesome, this is a MySQL or a Postgres table, for example. So if I get some issues in, I can create an issue and maybe update it and set the assignee and maybe go in and set done to true, and pretty straightforward. It's really, it's not bad. It's pretty standard. Does everyone know what I'm talking about here? Is this pretty familiar? All right. The issue is, well, we keep updating the table here. So, well, how did we get here? Look at the table. How did we get here? How did we happen to have some of the fields are there, some are null? What if I take away these events? Can you tell how it got to the table? How did it get to this state? I mean, you can't even tell unless you look at the events. Well, you can't even tell that. What seems weird about this table? Anyone notice? Well, yeah, assignee's null. So, well, who the heck cleared the assignee field? I didn't do it with these posts and puts, but someone obviously did. But now, even with these events, I have no idea how my database, it's in this uncertain state. The issue is the keyword mutable. If you do functional programming, you'll think of things as changeable, mutable, or immutable. If you have a table row that can be updated, you're going to lose the history. If you keep it immutable, you're going to keep your history there. So maybe the point is we can have a changeable state, but you should lock it down in the database, never update it. So what if we go ahead and lock this? We say, hey, you can insert it into here, but you can't delete it, you can't update it. Well, then if I do a post, I'll create a new row. And then if I do a put here, I'll create a new row for that, and another put. So each of my posts and puts, end up being one row here. So now, when I get it back, I can say, well, just give me the last one in the list. I have the whole record. I see exactly what happened with my data. It's there it's a historical record, and if I want to get it, just give me the latest one in there. It's not a very good appendable table, though. You usually want to do a few things to your tables to get them ready to be append-only. One of the two things is take away update and delete access. Absolutely take it away, make sure no one can do it. then test your code and see if it actually works. This way, you're never going to modify any row that happens here. It's a very straightforward way to do it. This is the syntax for Postgres, but should be similar for MySQL. Just take that away. The other thing is to make sure you have good columns for an immutable table. We have a timestamp. We have kind of a non-primary key, non-unique entity ID. Make sure you have a new unique ID too. Have a combination. Each row should have its own unique ID, but an ID that's for your entity that's changing over time. Lastly, make sure you know who changed your table. Have some kind of source, maybe a creator ID or other type of event that says, here's why we changed it. So in SQL terms, this is how we might create this. We might have ID be serial, that is, each one's unique, but we have an issue ID that says, we have a unique ID that's set up for this entity, which is going to change over time. Plus, of course, the created date, which is now called created because it never gets updated, and the creator ID. So now if I have this table, I have a few items. I have a creator ID, issue ID, title, and a Hey, now I know who set this to null. Okay, it wasn't that dramatic, but I made it a little dramatic. Point is, yeah, I can see what happened now. This was a state that kind of changed over time. Tracking the creator, I can see this. Do I know all about this? Not really, but I could tell the user ID who was behind it. I could probably go through the logs and find this out. The point is now I have a much more stable and resilient system. So that's kind of about immutable tables. But then I'm storing the state, right? Maybe I can even do better than storing the state at each point as we mutate this issue. We can go into event sourcing. Kind of an interesting name. I'm a little bit behind the times getting into this because this is from about 11 years ago in a great Martin Fowler article about event sourcing I recommend getting into. So you remember that I was doing posting and puts here, and I ended up with these nice tables. I've removed the assigning null thing because that's kind of a trick for the previous one. So what would you call the stuff above the line and below the line? Well, I'd call them events, really. I'd call it events above, events that changed my state, and then the bottom part was a list of different states. You could think of it as a flow diagram. The events are the edges, and the states are the vertices. So really, in our first model, we had kind of a crate that came in, and we got to the created state, and we did a assign, so we got to the assigned state. Finally, we marked it as done. We had kind of a complete issue that came in as an event that changed this. Although we got away with the whole update model, right? Now we're doing inserts, which are much better, but it's the same thing. You have an event, and it leads you to the state. But maybe that's not the right way to go. Maybe we don't need to store the states at all. We could just store the events and come up with the states, what they call projecting, to create like a virtual state. So we can move the inserts over to the events. Then we don't really need the states, do we? If I know these events, I could start with create and assign and complete, and I could generate the states. They're no longer necessary. I'm going back to how these actually got changed, not what was changed. I'm really keeping a record here. So when you design your table to do event sourcing, to store events, you're going to have to think about, one, where'd this come from? So we had states that I set as the creator ID, but this is an event. Maybe you want to think about where'd the event come from? Was it from a web browser? Did it come from another service at your company? Do you have a batch that originated this? See if you could keep track of where it came from. See if you could follow your event all the way through the service. I also put payload in there, which is not, like really type safe, but the thing is, you could have different tables, or you could store it in JSON or Kylo or some type of, very type safe binary storage. But now if you look at this, I'm storing the event. I have in the payload, I have the crate, I have the information there. I can play it back. It's really nice. If I do the create issue, then I can build an issue that's projected like this. If I run create and assign in that order, then I get to state 2. If I start from scratch and do 1, 2, 3, I get to state 3. So I don't need the states anymore. I'm just storing the events, and the events are the source of our data. Why do this? Well, you can write really well. If you're using Cassandra, or if you want to do something high write performance like Cassandra, append. Don't bother looking something up, reading it, modifying it in place. Make sure you have a database that can do really fast writes, and just append. Another issue is, It's not really command query responsibility segregation, but you're thinking in terms of events and then thinking in terms of states. The events are your commands that are coming in and changing your state. The queries are your state that you're building, which you could then query. You could think of your system, you could separate the command and query. You could do them on different machines. If you have a super fast system like Twitter, you can have all the commands that are coming in and maybe have something that says, hey, I'll get the latest states, the latest events that are coming in. Yeah, say nothing newer than 15 seconds. You can have something which kind of builds a nice state separately from the events. Anyways, I'm just saying it's a nice way to really scale up a big system. If you get to the point in your business where you have massive amount of traffic like this, you need to separate it, then give me a call, tell me how you did it, because that's hard to do. So you're probably doing well if you did that. The other thing is, one of the third or fourth thing is that you could see how you got here. You see what happens. You could trace the events. You could see how an event makes its way through your system. You could tell how the database got to where it is. You can replay them as we did. You could go 1, 2, 3. You could do them in order. You have control. You could generate the state at any time. And the last thing is, if you had a bad event, if you had like something which had to be retracted, you had someone who bought something and they had to unbuy it, you can always find a way to delete the event. You could put in a new event that marks the previous one as dead. You have control over this. You don't just have a row in a database. You have events and you could control the event stream. You could kind of version it. You can go back to your previous one. You could look at the log. I mean, this sounds like a development tool we all use, right? So that's one of the biggest reasons for event sourcing. You now have control of this. There's reasons, not to use it. It's a little weird. You're storing events. You're not storing state. All this stuff you've learned about SQL databases now works a little bit differently, so that part's true. You have to have an event-based system. If you don't have events coming in, if you don't have a system where you have something like events, it's probably not going to fit very well. And it's kind of non-standard. It goes in with the weird part. You're going to have to take time to think, do I want to store events? Do I have events to store? How am I going to store them? How do I keep the payload? How do I create the state? It's non-standard. There's all kinds of event frameworks out there. There's all kinds of CQRS things to do. Everyone has their own ways to store these events. So it hasn't quite boiled down into a very simple, okay, I'm lying to you, there's just not enough Stack Overflow answers yet. So maybe you want to hold off. Anyways, that was event sourcing. How are we on time? All right. Okay, we have another topic, synchronous versus async messaging. Remember this microservices thing I showed? Well, I've gotten better at creating arrows, so I want to show you this is what we're really doing with it. You have web stuff coming in and mobile coming in and services coming in. So you don't just have issues and users. Everyone's calling all these things. I mean, think of if I want to create an issue in my new system. You have web coming into issues, and issues talks to users and gets stuff back. Maybe it calls to issues to something else. It writes to its database. It's doing a lot. So if you have a regular type of REST API or microservice, and you're doing everything synchronously, you'll probably do something like this. You have a client that puts it, and you'll say, oh, I got to get the issue. Now I got to get the user and see if they're actually valid. Oh, that's good. Well, hey, please send a notification out. Then you're going to write it back to your database, send it back to the client. Client has to get it. That's 7 calls across the network that are pretty much done synchronously. So the point you should understand here is it's so easy. I'd say start there first. I mean, really, synchronous is great. Oh, God, what was the topic of this one? Anyways, synchronous messaging is very easy to do. I recommend it. I recommend doing it first. If you really need async, I think start with something easy that works well, then move into something else. So there's a few pros for using synchronous. As I said, it's so easy to use, right? You find out if it worked or not. I have this whole call stack, but if something failed, I get the failures back. I could find out right away. If I have to do a multi-part transaction, I could do the whole thing, and I'll have some type of error reporting that'll say, whoa, this didn't work. Last one kind of backs up number 1 there. I think it's a good point about synchronous messaging, good way to start. The big issue that you're going to find with it, though, is that it kind of takes a lot of time. So it's not very scalable. You have things waiting for each other. It's not very buildable for the future. Other issue is that it can be a little hard to manage issues. If you have some kind of failure in the synchronous, you can have everything fail, catch exceptions, say roll back, we're not going to do this. If you're not doing it synchronously, you may have to add batches that check things, that say, hey, what was the eventual consistency, or what eventually happened, or did we ever tell the user that we lost other data, or something important like that. So you lose that. So in our big web of different items that we have going on here and all these calls, by default you might say, well, let's start out, do them all synchronously, because why do it synchronously? Yeah, it's easy. All right. So it's easy, which is good. But if you want to start, I recommend seeing if you can make your issues, your microservices async. I mean, synchronous external APIs can be hard, especially if you have both web and backend code that's calling it. It's very easy to use a block and call. But if you make sure that your issues and users aren't blocking each other, that'd be great. If I had a cool new endpoint for issues and it drives up all the traffic, but it calls and blocks on users, then users going to have tons of traffic now. It means they're going to affect each other. There's no isolation or resiliency, which is one of the whole reasons for these microservices. Eventually, it's nice to think in terms of let's make as much as possible async. You notice I left the database still in red there. Harder to do. Some databases don't support it very well. But I'd say at least and usually if you co-locate your database with your microservice, which you should be doing, or at least have it to yourself, you should be able to make that fast. But it's nice to get to this point. So why do this async stuff? Well, I can't say it's easy. I used it for the previous one. Here's an easy way. Some easy ways I think you could try doing. You could get into it. I'm going with easy because, do we like easy? Yeah, I like easy. Okay. One is think in terms of your clients. You can have an async call, return status code 202, say, here's the eventual location. Grab an ID from a sequence, say, when it's ready, it'll be here, check back here, and it'll be done. If you're posting an issue, I can say, hey, quick, get a sequence, set up a location, 1, 2, 3, 4, 5, return to the sender, 202, still working on it. They can check it, and then you can continue with the rest of things. You can keep everything else synchronous, but at least your outside callers don't have to block. Another one is, well, we had all this issues and user stuff going back and forth. Is there any data you can cache? Remember it did a lookup to find the user? Well, can you store that somewhere? Can you put that in a cache? Can you put that in Redis or Elasticsearch or Dynamo or Cassandra or somewhere so you don't have to call the other microservice? If you can find ways to not call other microservices, you kind of have a big win there. Last issue I'll point out, which can be easy, is if you're making a lot of calls to other services, see if you have the ability to do non-blocking callbacks. It's popular in JavaScript. You could do in Java with Java NIO. I believe it's possible in Python. Have something which says, hey, I'm going to call this code when you're done. I'm going to return and go do some other stuff and not block any threads and not block anything I'm not going to worry about for now. It means it works well. Number 1 and 3 work together. If you have like a Python endpoint and you can call to create a location, you can say, okay, I have an ID for this. Here's your 202 back, and then do a non-blocking callback and say, okay, please kick off the rest of this, call my code when it's done so I can update things, and then be done with it. Moving beyond REST, a few things to look at. If you can do this, takes a little bit more. See if a pub sub model works. See if you really have to call a service to send an email, or can you just send it a message? Set up Apache Dynamo, to Apache Kinesis, for example, or have SNS talk to SQS and send a nice message out. On that note, you can have a message queue for every service. So instead of saying, I'm going to call you to send a mail, say, I'm going to give you a little message and put that in your queue so you could handle this. Last thing is, actor-based systems, very popular, Elixir, Erlang, Akka for Java and Akka. See if you can have a network-based actor system, which are made for supporting async properly. It's not, you're moving beyond REST for the interaction, but these might be ways that work for you as a simpler way to get into async messaging. Speaking of async messaging, that covers the async messaging part. I'm kidding, that covers the whole talk. Anyways, I'm Jason Swartz at ClassPass. Thanks, everyone.